So I had a YouTube subscriber ask me this question. They said, well, how would you analyze? So I made a video called, how do you solve three equations with three unknowns? And they evidently had a question about two equations with three unknowns. And I guess I've never really analyzed it. So geometrically, I would probably graph these in GeoGebra, and then maybe eliminate either an x or a y or a z, and find, because geometrically those are two planes, like two walls on a two walls, and so I'd graph those planes and see where they intersect, or if they do intersect. And so let's just do that. So first thing I would do is go into GeoGebra 3D. And so if you just quickly, where to get that is you go into geogebra.org, which, there's GeoGebra. And instead of Start Calculator, you go to this 3D calculator. And here's what you have. This is the GeoGebra 3D calculator, and I've already put the first equation in. And it's this orange plane that I have here. And so there is that plane. Okay, and then I would just go ahead and put the second equation in. So give me a second. And so now I put in the second equation, and it's this green one here. And as you can see, it almost looks like they're parallel, but they're not quite. So we need to zoom out. And so I'm just going to zoom out here until we find out where they meet. And if you see right down here at about -20 on the z-axis, it looks like they meet. And GeoGebra is kind of nice because you can go in here and intersect two surfaces. So and it tells you at the bottom, intersect, select two surfaces. So I'm going to select the left one and then select the right one, and it places the equation in there where the line where the two meet. And if you go back over here, you can see this equation. Now, this equation, I'll be honest, it doesn't mean a lot to me. That -20 kind of does, so that's kind of neat. And so I've got a little bit to learn in terms of this particular set of problems. So let me show you how I would analyze it, which I think would also kind of lead you to some pretty great places. Okay, so the first thing I would do is, eliminate the x. That just seems like kind of an obvious thing. And to eliminate that x, what I would do is take that top equation by -2. And so I'll just distribute that -2 through the whole thing. And so you'd have 2x minus 8y minus 2z equals -24. Oops, and it just kind of sneaks, got to sneak it in there. So -24. And then the bottom equation, I'll just leave alone. So -2x plus 8y plus 3z equals 4. And then I'll just add these two equations. And what you notice in this equation, which is kind of cool, and that's why I'm making the video, because I'm like, wow, this is kind of neat because it all falls together and it kind of makes sense when you put it in the geometric perspective with GeoGebra 3D. But when you add these, notice 2x minus 2x, these cancel out. That's 0. Maybe we'll do it with pink. And then these two cancel out. -8y plus 8y is 0. So then you're left with -2z plus 3z is just 1z. I'm not sure why that z is so weird. And then -24 plus 4 is -20. Geez. So z equals -20. There we go. Not sure why. It must be a goofy spot on the screen there. But so anyway, if you go to geometrically and look at this equation, you will see that yes, indeed, if you pull this so that the xy plane is parallel to your view and you look directly at it, so that you can just ignore. So now we're looking at the z x plane, I think, or maybe the zy plane. You can see that indeed at -20, those two lines meet. And if you look here, there's -20. on the graph. All right, so then if we look at this again, and if we eliminate two more variables, let's say we want to eliminate the z variable, we should be able to get this line here on the kind of superimposed on the xy plane. And so let's go ahead and do that. And so to do that, what I would do then is, let me erase this here quick. So let's think about eliminating the z variable. Well, if you eliminate the z variable, you would notice you got a 3z and a z. So if we took the top by -3, so we'll do this. We'll take this top equation by -3. And let me just put that down below here. And so you would have positive 3x minus 12y minus 3z equals negative 36. And when you do that and you add those two together now, you would have negative 2x plus x. Let's go back to pink, kind of like that color. You'd have x, and then 8y minus 12y is negative 4y. And then the z's cancel because you got 3z minus 3z. Bring down that equal sign. And 4 minus 36 is negative 32. And so this equation is going to show up in that xy plane, so let's go back to Geogebra and type that baby in there. This is what's kind of, just to me, it's really cool. But so if we type in x minus 4y equals, I already forgot the number, oops, negative 32 equals negative 32, and I hit enter. Let's see here. Oh, it didn't save it. So let me delete that. When I clicked off of it, x minus 4y equals negative 32. Yeah, so there it appeared in blue, and I'll change that color so it's easier. Oh yeah, there we go. Yeah, that worked good. And then let's change that color. I hate that blue color. It automatically chooses. Just it's hard to see. So we'll go to a pink. Okay. Yeah, not bad. And so there's that pink line right there. You can see it. And it's this equation here, x minus 4y equals negative 32, and it extends straight up perpendicular to the z-axis, or parallel with the z-axis, excuse me, perpendicular to the xy plane. And so what's cool is you go down and you look at this from the z-axis down, and literally it is the line x minus 4y equals negative 32. And so that's how I would analyze this type of problem. You've got this, it's hitting at z equals negative 20. You know that if you eliminate the z, it's going to cross the xy plane at x minus 4y equals negative 32. If there's some people who are interested and want me to, I'm probably going to go spend some time figuring out what this means, what these symbols all mean. I'm not exactly sure what the negative 3.76 and what the 7.06 mean. I can kind of get the negative 20, and what's cool is you got the 4 and the 1. We've got a 4 and a 1 located. We got 1x and negative 4. So we've got the start of something happening here, but it doesn't make sense that the 4 is there and the 1's there. So there's some things here I don't quite understand. But at the same time, we've got some great things happening. And And so I've got some things to learn. What does this all mean? But geometrically, if you break it down into just a couple of axes at a time, it's kind of cool to see that indeed, if you eliminate x and y, it meets at negative 20. And if you eliminate z, you've got this line of x minus 4y equals negative 32. And so, kind of cool. I'm not going to lie. I was just very intrigued by the problem, and the geometry is just really interesting to me. So I hope this helps. Doesn't get into the great detail on what some of this stuff means, but it at least gives you some of the geometry based on what you maybe understand in Algebra 1 and Algebra 2 in a basic geometry course, which is what I'm an expert at. So thanks for listening, and I'll see you next time.